Hi guys, you're welcome to my channel. So today I quickly want to make some clarification by proving these given equations. That is the root mean square equation. However, when they say root mean square, I want us to understand what they mean literally. So I found a lot of students and some colleagues find this difficult to prove because of what we think they are saying. Let's start from what we think they are saying. When I say root means square, it means if I have some values, let's say I have, I don't want to use v this time around. Let me say I have f square to be some values, f square 1 plus f2 square plus f3 square. Are you seeing it now? These are squares, this sum of squares, right? So if this is sum of square, if somebody say root means square, what it simply means is that I should find the mean of okay, let me take it like this. What it simply means is that I should find the mean of this sum of square. That will be f1 square plus f2 square plus f3 square, all divided by 3, right? So that will be the mean of this square, right? But if you now say root mean square now simply means that I square this. That's what root mean square means literally. However, when you are given an AC circuit and you are talking about root mean square, we are not talking about the same thing. I hope you understand where I'm coming from now. This is not the same thing we are talking about, because I often see a lot of colleagues or students trying to prove this equation by addressing it in this manner. What do I mean? Let's say this is a graph that shows the AC current or AC voltage. So let me say is AC voltage. So here is going to be V naught. If I plot V on this vertical axis, and this is the time. Now, what a lot of us usually think is that this is the peak V naught and this is the peak negative V naught. Now, if you want to calculate the power of this AC supply, you cannot use this one, and neither you cannot use this. I'm trying to reiterate reason why we have this equation. If you want to calculate power and you decide to use V naught, that means you are going to overcharge. And or if you now use negative V naught, you are going to be undercharged. Best way you can do this is to find what? The average of the two. But if you are trying to find the average of the two, your result is going to what? Become 0, which is what you need to avoid, because that means you are not going to charge anything at all, and that is worse, right? Now, we're not saying we can avoid having 0 by squaring each of these. So look at what I'm saying. We want to avoid 0 now. So we are going to have V naught square plus into bracket negative V naught square divided by 2, just like what I'm saying there. So this is going to be 2 V naught square all over 2, isn't it? So by the time you said this is going to be the mean of the square, isn't it? By the time you say want to square it now, what you're going to be having is going to be square root. It's not even square root of V naught. What you're just going to be having is going to be V naught. And that is not the same thing as the equation that they said we used to represent the root mean square voltage or current that we are going to use to calculate the power that we are looking for. So that's exactly a wrong way of understanding what they are saying. So let's get to understand it better now, literally. Now, when you talk about the root mean of this particular function, I want you to understand that what gives you the value of every curve that you have here is not just a number, but an angle. And it's not just an angle, it is an angle in radian, not an angle in degree. Am I making sense now? So if it is an angle in radian, to make this graph a bit simple, because normally now, I now need to divide this graph into whatever numbers of parts I want. Like I can divide this like this and make this one the first one, second division, third division, fourth division, fifth. So I can say I divided this graph into 10 or what have you. And then I now need to start giving them a value at interval, but that might take times a bit. However, I know that for this graph to be at this point, that simply means that here is 0. Why is it 0? Because sine of 0 is going to give us 0, isn't it? Cool. And to this point, it's going to be pi. I get it now. And down to this point, it's going to be 2 pi. Are you seeing where I'm coming from? So where is the average here? Average of this entire graph is this point here, isn't it? So I can find the value of this average using this particular formula. Said average of a function is given as 1 all over b minus a, the integral from a to b of f of x dx. Where do I get this from? Of course, if you have done calculus, I think Cal 2 students should understand this. That should not be a problem. However, if you still find it difficult on how we get this, you can let me know in the comment section. I'm going to make a video proving this to you. So if this should be the case, let me show you the graph that produced this so that you can have a bit of understanding. Let's say I have a graph of f of x. This is f of x, and this is x. So if the graph goes like this, here is point A, right? And here is point B, right? And here is point, let me say here is point C, and here is point B, for a better understanding so that I can suit this. The average of this graph is going to be that I have the average to be 1 all over from here to this place. That will be b minus a, isn't it? Then the integral of a to b of f of x dx. Have we seen it now? So that's how we get this. So if you want a better explanation, you can let me know. But why do I give you this? It's for me to be able to relate the next equation I want to write now to this given graph. Remember that we said we should not consider the entire graph. We just want to consider this one. So if we consider it, because it's like a repetition, however, but I don't want to go into that so that you're not going to get confused. We want to look for the average of this one. That is from 0 to pi. We want to look for the average of it. Am I making sense now? So for us to look for the average of this, we just formally think that is this. So look at what I'm going to do. So the average of this particular one, this is the right one we are looking out for, is going to be from 1 all over, so this is going to be pi minus 0, just like I have b minus a. Am I making sense? Then the integral from 0 to pi of, instead of f of x, what function do I have here? That's voltage, v, right? So I have v into bracket t, because v is a function of t, just like f of x is a function of x dt. Have you seen this now? So this is the average equation that we obtain from here. And the same thing is what you can do for I. So if it is I that I have here, that is current against time, it's still going to be the same thing. Just remove this v and put what? I. So if this is what I have, let me call this one equation 1. So from that equation 1, we can now proceed and get something better done. So we said we want to look for the what? The root mean square. So looking for the root mean square simply means that I have to what? Obtain the square of this function. That is, find the mean of the square of this function. So what does that mean? I will have that average, that is average root mean square or mean square. Let me just put it as mean square so that you understand. So mean square voltage is now going to become 1 all over pi, the integral from 0 to pi of v square into bracket c dt. Have you seen what I'm having now? So root mean square voltage will now become, root mean square voltage will now become the square root of 1 over pi, the integral from 0 to pi of v square, of v square dt. Have you seen this now? I believe you are following. Now, this particular one I have here now, I cannot really do much things with it. So because I can't do much things with this, I need to think of something else to replace this. And what's that? Firstly, you need to understand what this V simply means. This V is called instantaneous velocity. that is DC equivalent voltage. I've explained this in my previous lecture on AC circuits. You can check the description part of this video if you like to give it a look. So this is an equivalent DC current, and this is given as V equal V naught, where V naught is the peak voltage, sine into bracket omega t. Have you seen this now? So I'll call this equation 2. I'll now use this equation 2 to replace what? V in this place. And that will make me have the root mean square voltage to equal the square root of 1 over pi integral from 0 to pi of, instead of V square now, I will have V naught square sine square omega t dt. Have you seen this now? Good. So if this is what we have right now, you can see that it's making sense now. We now have enough things to play with. Because one thing about proving an equation is about you expanding the current equation you want to prove so that it keep on making sense, right? So here now, I have a lot of things to dance with. Now, but before we go on, the first thing I want to do is to take out anything called constant here. V naught square rather, V naught square is a constant, isn't it? So I'll take it out because it's square. Taking it out of this root will make it become V root mean square equal V naught, the square root of 1 over pi, the integral from 0 to pi of sine square omega t dt. Now, when it comes to integral of exponential, especially if it is a transcendental function, just like you have a sine here, it might be a bit tricky. However, I get you. I have to think of how I can get rid of this word square so that I can have everything to be linear instead of having it to be an exponent. And how can I do that? I can do that by looking for a way of replacing sine square omega t. And that will be easy for me if I recall from compound angle. So recall that from compound angle, recall that sine square omega t is equal to 1 minus cos 2 omega t divided by 2. Do you understand? So we got this from saying the expansion of cos 2 omega t. When you expand cos 2 omega t, you should be able to make sine square omega t the subject of the formula, and you're going to have this. So if you find that difficult as well, check my lecture on trigonometry. I covered the expansion of all these angles there. So that's not the aim of this video. So let's go on by putting this in place of this. So that makes us have that the root mean square voltage is equal to V naught, the square root of 1 over pi, the integral from 0 to pi of, into bracket, 1 minus cos into 2 omega t divided by 2 dt. Are we making sense? It's enjoyable, right? It makes sense, especially if you are doing it inside a book without explaining it to somebody. It looks like magic. All right, so let's distribute this with the inside these brackets now so that we have something making sense to work with. So we have that the root mean square voltage is now V naught, the square root of 1 over pi, the integral from 0 to pi of 1 over 2 dt, minus 1 over pi, the integral from 0 to pi of cos 2 omega t dt. Have you seen this now? Let me just bring it out here. Yeah, to avoid unnecessary repetition. So this 2 is a constant, and 1 over pi is also a constant. So when 1 over pi open this bracket, I should have this. And I think that's awesome. Okay, so let's move on. So permit me to clean this. All right. So we have that the root mean square voltage is equal to V naught, the square root of, this now will be 1 over If you integrate 1 over 2, that will give us t over 2. So we have, let me just put it like this so that it will be easy for me to simplify. So I will have 1 over pi into brackets t all over 2 from 0 to pi. Then the next one is going to be minus 1 over 2 pi into bracket. By the time you integrate cos 2 omega t dt, your result is going to become sine 2 omega t divided by 2. Now, this one here, let me just write it better so that you're not going to get it confused. This is supposed to be 1 over 2 pi. So this 2 is underneath. Do you understand? So this is over 1. Let me put it like that better. So this is going to now be what? From 0 to pi. Do you understand this now? So what next now? With your ego high, there's no need of you stressing yourself. By the time you do the simplification of this definite integral, you are going to have that the root mean square voltage is equal to V naught, the square root of 1 over 2. Have you seen it now? By the time you simplify this, so if you simplify this, you have this. Therefore, I have that the root mean square voltage is V naught divided by the square root of 2, which is what we intend to prove. So if you want to do for current also, just exactly the same way, nothing changed. I hope you understand this now. So if there is any equation you would like me to prove, you can let me know in the comment section. And